This is section 6.1, the first section in unit 6. The I can statement is I can perform transformations of functions. So we're going to write the word transformations here. Transformations. All right, now you've dealt with transformations before, but there's lots of things that we're going to need to deal with here. Lots of details that we're going to need to keep track of. So the warm-up here says when we transform something, this going back to maybe some things that you learned in 8th grade, when we transform something, we change it. So when we transform something, we change it. And then here's a big idea. We're going to have several versions of this statement right here. We've talked a little bit about this before, but the big idea here is that functions make shapes when we graph them. Functions make shapes when we graph them, and we're going to be transforming those shapes. So we know a graph is a picture of all the points that make a function true, and we call the most basic shape that a function makes, we call it a parent graph, or we call it a parent function. We've studied linear functions, and we've also studied exponentials. So we'll just write the word exponentials right here. All right, and you may remember that we also learned a little bit about piecewise functions. So we've kind of dealt with those three. And what we're ready to do now is we're ready to deal with a very powerful concept that is going to allow us to change those functions and change those shapes so that we know exactly what they're going to look like and how the function would be written. And another word for change is transformation. So transformation. So everything that we deal with today and for the next couple of days and on this unit, we're going to be dealing with things that change functions and transform them. So we'll use that word pretty much exclusively. So recall the vocabulary for transformations. A translation is a slide. In other words, it is a shift. We can shift things to the left or to the right or up or down. And then a reflection is a mirror image. It's also known as a flip. So we can flip it across a line of symmetry. And then a dilation is a stretch or it's a shrink. So stretch or shrink is a dilation. A flip is a mirror image across a line of symmetry or reflection line. And then a shift is when we slide the graph up, down, right, left, do something like that. Now, transformations with functions work slightly different than transformations with figures that you may have learned previously. The difference really comes here when we change the function before it makes the shape or after it makes the shape. So do we change the function before it makes the shape or after it makes the particular shape that comes from that function? So I've got some stars by these. These are really important. These are some key ideas. If the transformation changes the x before the function makes the shape, then it changes it in the horizontal direction. Horizontal direction. And let's pause for just a second and think about that. It should make sense that if we're changing an x, that we're going to change in the x direction because the x direction is a right and left. It's a horizontal direction. Now, if the transformation changes the function after it makes the shape, so after it makes the shape, then it changes it in the vertical direction. And we're going to talk about how all of these work, and we're going to do lots of examples so that this can kind of sink in. And we'll try and do these kind of slowly so we can get these all figured out. So let's take a look at this one right here. If we've got a regular old function, so say y equals f of x, so we could use regular equation notation or we could use function notation. So if we've got a parent graph or a parent function, and I've got an example that we'll use over here repeatedly, if we've got an x and then we either add h or we subtract h, this is going to be a horizontal shift. Horizontal shift. So we're going to be sliding the graph to the left or the right. And you can see that what's happened here is we've changed the x. It's inside the parentheses there. Now notice that on this one we've got the same operation. We've got adding and subtracting. We've got a different constant right here. Here we've got h and here we've got k. Here we've got f of x, and then we're adding or subtracting k. That is going to be a vertical shift. That's going to slide things up or down. So again, notice changing the x, we get a horizontal change, and then if we change this after it's made the shape, then we get a vertical change. We get a change in the y direction. And then we've got f of x, and then we've got multiplied by a. Again, we normally use letters toward the beginning of the alphabet to represent constants, not really variables. So think of this representing a number. So this would be either a vertical stretch or a shrink. Vertical stretch or shrink. It could also be a flip. It could also be a reflection. We're going to take a look at each one of these. And if you know all of these and know them really well, then you'll be able to graph any type of transformation for any function, any graph that you'll come across. So we're going to look at this weird shape over here. So this is a piecewise function right here, and we're going to use this as the parent graph for all of the examples that we're going to do on this page. So what we'd like to do first is we'd like to complete the table below with 5 key points that define this piecewise function. So the 5 key points are this one, this one, this one, this one, and this one. We do have points that are in between here. We could grab those, so we could list more if we wanted to. So I'm going to put a yes right here. But these key points right here, those 5 kind of define, as long as we connect them with lines, they kind of define the shape right here. So we've got x right here, and then we've got f of x over here. And to make these kind of nice and neat, because it's going to help down the road, I put down that this is going to be f of -4. So we need the function value at -4. So we're going to go back here to -4. The value of the function, the y value, is -1. And f of -1, we'd go back 1 and figure out where the function is. It's up here at 2. And then at 1, it's also 2. At 3, we want to know what f of 3 is. It's 0. And then we want to know what f of 4 is, so we go over to 4 in the x direction, and then we go up here to 2. So these 5 key points are the ones that define this. So we've taken this graph and we've turned it into a table of values over here. So I'm going to slide this down here, and we're going to take a look at what some of these do. Now, one of the easiest transformations to do is called a vertical shift. So it says perform each transformation, then sketch the graph. And it says, how do you think the graph will be transformed? So take a look at this right here. So our new graph is going to be y equals f of x, the old shape, the old function, and then we're going to add 2. So think about that for just a second. Think about what we talked about up above. Maybe you know which direction it's going to move it. But what we're going to do right here is we're going to say, okay, the x in this case is -4. So I need f of -4, and then I'm going to add 2 to that. So f of -4 is this value right here. So it's -1, and then I'm going to add 2. So that's going to be 1. So I'm going to graph an x value of -4 and a y value of 1. So I'll come over here, -4, and then up 1. So I'm going to put a dot right there. We're going to do the same thing on this one. So we're going to find f of, we're plugging in a -1 here. So f of -1, and then we're going to add 2. f of -1, that's going to be 2. So then we're going to do 2 plus 2. We end up with 4. So I'm going to graph this point. Here's the x coordinate, and here's the new y coordinate. So -1, 4. So it looks like that. And then f of 1, so f of 1 plus 2. Again, we're just putting a 1 right there. Whatever shows up in this column, we're putting it right there. So f of 1 plus 2. So f of 1 is 2. So this is 2 plus 2. That equals 4, so I'm going to graph this point, 1, 4. So it'll look like that. And then we're going to plug in a 3. So this is going to be f of 3 plus 2. f of 3, that's going to be 0 plus 2, just grabbing those function values over here. So we end up with a 2. So we're going to graph 3, 2, so over 3 and up 2. And then 4, we're going to plug in a 4. So f of 4 plus 2. f of 4 was 2, and we're going to add 2, so we end up with 4. So we're going to graph the point 4, 4. So over 4 and up 4. Now, those are the 5 key points. We graphed those, but remember, we need to connect those with a line so we get the rest of the points that make this function true. So here's the entire picture right here. So it looks like that. Okay, now if you compare this one with the one up here, you'll notice that what happened is we basically took that original shape that went like this. So I'll go ahead and draw it in right here. It went like this, and we moved it up 2 units. So taking f of x and adding 2 moved it up 2 units. So we take the shape and we slid it up there. So you might want to think about this one right here. What's going to happen when we do f of x minus 3? I'll come over here and we'll do this again. So we're going to do f of -4, and then we're going to subtract 3. So f of -4, that's -1 minus 3, so that's -4. So we're going to graph -4, -4, so back 4 and down 4. And I think what I'm going to do over here is I'm going to shorten this just a little bit. I need to find f of -1, and then I'm going to subtract 3. So I'm going to find all of these, and then I'll come back and graph these. So I'm going to grab this value right here, so that's 2, and we're going to subtract 3, so we get a -1. So we'd graph that one. And then we're going to graph f of 1 minus 3. f of 1, that's that 2 minus 3, so we get -1. So that's what we'll graph there. And then I'm just going to skip this right here because we always grab that one. So I'm going to do 0 minus 3, so we get -3. And then let's see, we get, for this one, this is going to be that value right here. So this is going to be 2 minus 3, so we end up with -1. So these are the ones that we're going to graph. negative 4, we already graphed that one. -1, -1, so we're right here. 1, -1, so we're right there. 3, -3, over 3 and down 3, and then 4, -1, over 4 and up 1. So here is that completely transformed graph. Now, if you compare this with the one up above, and I'll just go ahead and do a dotted version of this here for just a second. The original one looked like this. Okay, so what we've done here is we've moved every one of these points down 3. So let's come down here toward the bottom, and it says the tables contained in were the original 5 function values. We could pick other ones if we wanted to, like we could have picked -2 and -3 and so forth. Okay, but this change right here, what happened here when we moved it up and when we moved it down, this is called a vertical shift. Okay, now vertical shifts do exactly what you'd think they would. So I'm going to write exactly here because the shape was already made. So think of it this way. We're going to take f of x, we're going to take that original shape right here, and then we're just going to take all those function values and we're going to add 2. So it's going to take the graph and it's going to bump it up 2 units. Every one of those is up 2 units. Oops, that should actually be right here at -1. Let me make that look right. Okay, so we took every one of these and we bumped it up 2 units right here. On this one, we took every one of those original function values once the shape was already made and we bumped them down. We went straight down 3 units. So it kind of does exactly what you'd think. You would think adding 2 would move it up and you'd think subtracting 3 would move it down, and it does. So slide over to the next page. Let's talk about a general format that we can have for vertical shifts. So if we have y equals f of x plus or minus k, and I do want you to notice that the k is outside the set of parentheses. Okay, this is how we're going to be able to tell whether it changed the function before it made the shape or after it made the shape. So that's going to be a big deal. Okay, this type of transformation changes the function after it made the shape, so it does exactly what we think it should. And when we add k, so we'll take care of that first one right there, it moves the shape up. So when we add, it moves it up, just like you'd think it would. We add to the y values here. And when we subtract k from f of x, so if we have f of x minus k, it moves the shape down. So we're going to put down right here. Okay, moves it k units down. And what we do there is we subtract from the y values. All right, now the next transformation is a little bit more complicated. It's one of the harder ones to understand. It's a horizontal shift, and these are just a tad more complicated. Now for reference, I've got the table from the other side, and I've got a very small version of what the original function looks like, that original parent function. So let's take a look at what happens here. It says, which way do you think the graph will move? So we've got f of x plus 2. Now notice that unlike the last one, where the 2 was outside the set of parentheses, so let me slide up here, outside the set of parentheses and outside the set of parentheses, on both of these we're using the same operation. So we're adding 2 here and we're subtracting 3 here. But now we're doing it with the x inside the set of parentheses before the function makes the shape. So think about what that would look like and see if your guess is correct. So let's go ahead and do this one right here. Now I've chosen these values right here for a reason, and you'll see why. So x is -6, so I'm going to do -6 plus 2. -6 plus 2 means that this thing right here in parentheses acts like a -4. So we need to find the function value at -4. The function value at -4 is -1, so this is what we're going to graph. So we're going to graph -6, -1. So we're going to go back to 6, and we're going to go down to -1. Okay, next one, we're going to plug in a -3 right there. So we're going to go -3 plus 2. That's a -1. There is an f of -1. F of -1 is 2, so I'm going to put a 2 right here, and we're going to circle those. Those are the ones that we're going to graph. So this is going to go -3 and then 2, so we'd be right here. And then we're going to plug in a -1. So this is -1 plus 2. -1 plus 2 is 1. So f of 1, that's this right here, so there's a 2. So we're going to graph -1, 2. So back 1 and up 2. And then the next one, we're going to plug in a 1. So we've got 1 plus 2. Notice that we're adding to the x value. And then we're plugging that right in here, and we're figuring out, okay, what is the function value on that original parent graph? That's going to be 0. So we're going to graph 1, 0. And then let's see, we've got 2. So we're going to do a 2 plus 2. So when we add 2 to x, we get a 4. Is there an f of 4? There is. That's a 2. So we're going to graph 2, 2. So we're right here. And then let's plug in a 3. And this is why you'll see it's kind of a good thing that I picked the x values for us. So we're going to do 3 plus 2. That's a 5. Is there an f of 5? Well, there's not on the chart, and that's not in the domain of the original function. So I'm going to put an NA right here. There is no function value. So what that means is this is the entire graph. And of course, we're going to go ahead and connect this. So it goes like this, this, connected with line segments right here. And then let's draw what the original one looked like. The original one looked like this. It went from -4, 1 up to here, went like that, went down to here, and then went up to here. So if you take a look at the dotted original version, what's happened here is we've taken every one of these points, like this one, and we've slid it back 2 units. Slid that one back 2 units. Slid that one back 2 units. Slid that one back 2 units. Okay, so this is moving it in the horizontal direction like we talked about. A little bit strange that it moves it in this other direction, but let's try this next one. Now, if this one moved it 2 units to the left, you might be able to take a guess at what this one's going to do, but let's check and see. So when we plug in a -1, so wherever there's an x, we're going to put a -1. So this is -1 minus 3. This is a -4. So f of -4 is -1. So we're going to graph these two. And again, I'm going to go ahead and fill out the table. Then I'll come back here and graph this. Let's see. So this is going to be 2 minus 3. We're plugging a 2 in right there. So that's a -1. There is an f of -1. It's 2. So we're going to graph this. We're going to plug in a 4. 4 minus 3 is 1. So let's see if there's an f of 1. There is. It's a 2. And then a 6. So this is 6 minus the 3. Like they've told us to do there, that's f of 3. And f of 3 is 0 right from the table. We're going to graph that. And then 7. So this is 7 minus the 3 they're telling us to do there. That's a 4. So 4, the function value at 4 is 2. So we're going to graph that. And then let's check what happens when we do an 11. If we do 11 minus 3, we get an 8. There is no function value in the table like that. And remember, this was the end of it. 8 would be over here. There is no function value there. So I'm just going to put NA right there. So here are the 5 points that we're going to graph. So -1, -1 right here. 2, 2, so over 2 and up 2. Over 4 and up 2. 6, 0, so right there, and then 7, 2. So it looks like this. So here is our transformed graph. This is what the new one looks like. Oops, let me make that look right. Okay. The old one, remember, started right here and went up to here. So it went like this, then flattened off, went down to this, and then went right there. So you'll notice that the old one is the dotted one, and the new one is kind of the solid one right here. And notice what happened here. We took this point right here that was kind of this upward swinging piece right here. 1, 2, 3. We moved it over 3 places. We took this one, moved it over 1, 2, 3. We took this one, moved it over 1, 2, 3. Okay, so is this the direction you expected? Well, probably not, because you would think that if you add 2, that you would move it to the right 2 units. If you're going to change it in the x direction, you'd think it would move it to the right, and you'd think this would move it to the left. Well, it doesn't. It actually does the opposite of what we'd think it would. So let's go ahead and write down opposite. It does the opposite of what you'd think. Now, here's what they can look like in general. So this is going to be y equals, our new function is going to have the x, and then we're going to add or subtract another number. We'll call that h. So f of x plus h. And again, note where the parentheses are. They're around the x plus or minus the h. What is inside or outside the parentheses is a really big deal, as we've already seen, because on this one we had the same plus 2 as we did before, but before it was outside the parentheses. Here they're inside the parentheses. So here's what happens. This type of transformation changes the x before it makes the shape, so it does the opposite of what we'd think. And here's why. When we add h to x, it makes the shape h units sooner than it normally does. So what it does is, instead of waiting until we get here to start making this shape, by adding h, by adding 2, it actually makes the graph 2 units sooner. So when it makes it sooner, it moves it to the left. So let's put left right here. And when we subtract h, it makes the shape, let's see, h units later. than it normally would. It doesn't make it sooner, it makes it later than it normally does. And if it makes it later, so normally it would start making the shape at -4, but because we've delayed it by 3 units, it doesn't start making that shape until 3 units later. It doesn't start making function values till we get to -1. Okay, so in that case, it moves to the right. Again, a lot to digest here. Kind of strange that it works out that way, but it does. And with some practice, you can get really good at these. Now, the last one is this type of transformation. So you'll notice that this is different. We're not adding or subtracting. What we're doing here is we've got a multiplier out here. We've got a factor of 2 out front on this one, and we've got a factor of 1/2 here. Now this is actually slightly easier, so I'm going to fill out the table, and here's what the table would look like. We're going to do 2 times f of -4. Well, f of -4 is right up here on the table. It's -1. So that's a -2. So we're going to graph these points right here. X is -4, y would be -2. Let's do this one. This is going to be 2 times f of -1. -1, that would be 2. So this is 2 times 2, so that's going to be a 4. And we're just going to keep going. This is 2 times f of 1. f of 1 is 2, so this is 2 times 2, so that's going to be a 4. And then this is going to be 2 times f of 3. Again, I'm just putting whatever this value is here in the function, and then I go find that function value. So this is going to be 2 times 0, which is 0. And then we've got 2 times f of 4. So f of 4 is 2, and we end up with 4. So here's what we're going to graph. Here are those 5 key points there. So we are going to graph -4, -2. So back 4 and down 2, so we're right here. -1, 4, back 1 and up 4, 1, 4, so forward 1 and up 4, 3, 0, so we're right there, and then we've got 4, 4, so over 4 and up 4. So this is what we've got. Let's go ahead and connect these 5 key points, and we get this shape. Now I am going to come back here and I'm going to graph that original shape right here. I'm going to go ahead and change into blue right here. So this is going to be from here to here to here to here. This is what the original one looked like. And maybe you can tell what this is going to be based on some of the descriptions that we had earlier. What's happened here is we've made this graph twice as tall as it used to be. We used to be at 1 right here. Sorry, we used to be at 2 right here. We bumped it up and it's twice as tall. It's at 4. Used to be at 2, bumped it up twice as tall. Used to be at 0. Well, if you double 0, it stays 0. But this function value right here was -1, so if you double that, you get -2. So what's happened here is we've kind of vertically stretched this out. Okay, and then let's take a look at this one over here. You might be able to guess what this one does. We're going to do the same thing, but we're going to be multiplying everything by 1/2. So this is going to be 1/2 times that first function value. So that's -1. This is -1/2. So that's what we'll graph. We're going to do 1/2 times this next function value. That's a 2. So that's going to be a 1. And then same thing on this one because we have a repeat of those function values there. So that's going to be a 1. And then this would be 1/2 of 0. That's still going to be 0. So we're going to graph 3, 0, and then half of the function value at 4. That's going to be a 2, so that's going to be 1. Okay, now let's go ahead and graph this one. Let's see, this is going to be -4, -1/2, so back 4 and down 1/2, so we'd be about right there. -1, 1, so about right here. 1, 1, about right there. 3, 0, we can get that one right on top of that, and then 4, 1 would look like this. So let's go ahead and make that solid. So this is the transformed graph. And again, I'll come back here in blue and let me show you what the original one looked like. Not much of a change here, but it is definitely shorter. All of these points are smaller than they used to be. Like instead of having a y value of 2, we've got a y value of 1. It was cut in half. Instead of having a y value of -1, it's a y value of -1/2. It's been cut in half. So this was a vertical stretch. It made everything twice as tall as it used to be. This is a vertical shrink. It made everything half as tall as it used to be. And again, notice that this is outside f of x, so it did make a vertical change. Okay, so these are vertical stretches and shrinks, and they do exactly what you'd think they would. Remember, when we change it vertically, it's going to do exactly what we think it should because that shape was already made. All we're going to do is we're just going to change the y values. So vertical stretches and shrinks look like this. Y equals a times f of x. Again, notice that the a is outside the parentheses. That tells us what type of change it's going to be. It was made after the shape was created, so it's going to change it in the vertical direction. So again, this transformation changes the function after the shape was made. So after the shape was made. So it does exactly what we'd think. When we multiply a by f of x, it makes the graph, the y's taller or shorter than they used to be. So we multiply the y values by whatever this number is. Now, whether those function values are taller or shorter, bigger or smaller than they used to be, depends on what a is. So if a is greater than 1, so in other words, if a is bigger than 1, and I'm going to put bigger in parentheses, you might see why in the next couple of sections, okay, then the y's are taller than they used to be. So if we're multiplying by a number that's bigger than 1, like this right here, the y's get bigger. That means they get stretched out vertically. And if a is greater than 0 and less than 1, so in other words, so let's say a is a fraction or a decimal, okay, a fraction or a decimal between 0 and 1. I think you know what I'm kind of meaning here. Okay, then the y's are smaller than they used to be. So we multiplied by 1/2. They get shorter than they used to be, so they're smaller. Now, once we know what these transformations do, we can describe it, we can sketch it, we can find all the points and fill out the tables, and we can kind of do that in any order that makes sense to us. So once you come up with a description for it, once you can describe it, the rest of the stuff is usually pretty easy. So we're going to kind of focus on that. So what I'd like you to do right now is go ahead and do the self-assessment, and then we're going to take a look at problems 1, 7, and 15 from the assignment. Okay, so here's the practice worksheet for section 6.1. It's the first one, 6.1a, and we're given this this piecewise parent function right here, along with the table of the values that would work in here. So we're going to take this and we're going to do all these transformations down below. We're going to do example number 1 or problem number 1 right now. So I'm going to slide this down here. And it says, complete the table, sketch the resulting graphs, and describe the transformation. And then it says, hint, it may be easier to describe the transformation first, then fill out the table, and then graph it. So let's take a look here. This is going to be f of x minus 1. So notice that we've got f of x, and then outside there, we're going to take this and we're going to subtract 1. So the description for this is, if it's outside there, it's going to be a vertical change of some sort. So we're going to put vertical. Okay, vertical, and I guess we could abbreviate that as VERT, period. Vertical shift. Vertical shift. And what's going to happen is this is going to move it down 1 unit. So we're going to take this shape and we're going to move it down. So instead of being right here, we're going to bump it down. So that would be 4, 2. So I'm going to go to 4, 2 right here. And then this one, we're going to bump it down 1 unit. So this is going to be -1. Instead of -1, 0, it's going to be -1, -1. And then this one is 1, 2, so we're going to go down 1, so this would be 1, 1. And then this is 1, 2, 3, and up 2, so we're going to go 1, 2, 3, and only up 1. Notice how that flattens out like it should. And then we're going to go over 4, and we normally go down 1. We're going to go down 1 more than that, so we're going to go 4, -2, so we're going to go right here. So let's go ahead and draw what this looks like. Looks like that. Okay, make that look a little bit better. Okay, nice straight line there. So that's what it looks like. Now you'll notice the shape is identical. Hopefully this probably should line up a little bit better, but you can kind of see that the shape looks good there. So that's awesome. And you can see that what's happened is we've moved this down. So I'm going to come back here and I'm going to draw this one, the dotted one right above it. So that one started here, went to here, crossed through here, and then went like this, and then went down here. So this is the original one. If you want to take the time to draw that in a kind of a dotted fashion right here, you can see that the blue one was the original one, and then all we did is we took this one and we slid it down. So we've got the graph, and we do want to fill in the table here. So let's go ahead and do -4 and -1 and 1 and 3 and 4. And if you want to do the x values, then the y values, or do them together, that's fine. So this one was -4, 2. So we got that one. -1, -1. And this one is, let's see, this one is 1, 1. And this one is 3, 1. And this one is 4, -2. Now, I did it in that order because I just saw that, well, this is going to move it down. So I graphed it and then I found the points. But I want you to take a look at this. Notice that all of these are the same because what we did is we did a vertical change. So notice that these values right here, these these x values are the same as those values right there. A vertical change does not change the x values at all. And look what happened here. So I'm going to highlight this. Look what happens on these. Every one of these y values, every one of these function values got 1 taken off it. So 3 minus 1 is 2. 0 minus 1 is negative 1. 2 minus 1 is 1, 2 minus 1 is 1, and then negative 1 minus 1 is negative 2. So we could have done that same thing by noticing, hey, I'm just going to take the y values and I'm going to subtract 1. We could have come up with the table, then graphed it, and then we could have described what it did. So either way would be fine there. Let's slide down here and let's take a look at number 7. So number 7 is on the other side. You've got a whole bunch of graphing to do on the front side, and then on the back side it says just describe the transformation. So let's take a look here. It says y is equal to 4 times g of x. Now remember, this is outside the parentheses. This is outside g of x. So we've already made the shape, so this has got to be a vertical change of some sort. So this is going to be a vertical change. And remember, we're multiplying, so that's either going to be a stretch or a shrink. If we're multiplying by a number that's bigger than 1, that's going to be a stretch. So this is going to be a vertical stretch. Okay. Now, another thing that we could add to this is we could kind of say what's going to happen here. All of the y values are going to be times by 4, so they're going to be 4 times taller. So I'm going to put 4 times taller. 4 times taller. Y values. Let me put that out front there. Y values are going to be 4 times taller. Y values. Y values 4 times taller. Now, you don't have to put that, but that's very descriptive, and that would be really helpful for you figuring out how these work. And the other one we're going to take a look at is number 15. So it says we've got h of x, and it says it's shifted 1 unit to the left. So the instructions here say write a transformation of that function given the description. So we want to go 1 unit to the left. So this is a horizontal change. So remember, horizontal change have to happen inside the parentheses with the x. So we're going to do h of. Now, if we want to go to the left, let's see. Normally, if you want something to go to the left on the x-axis, we'd subtract. But remember, we need to do the opposite here. So we're going to do x plus 1 right there. And that is it. That's the answer. And again, the reason that moves it to the left is because this is going to make that exact same shape. Whatever h makes, we have no idea what it looks like. But whatever that shape makes, it's going to make it 1 unit sooner. So that's going to be 1 unit to the left. All right, you've got several problems to practice here. All of them are good. These are not, this is almost more difficult to explain than it is to actually do. So give this some practice. We'll take several days on this and get this all figured out. Good luck on the assignment.